Hello folks, let's continue with the workshop. So in backup and restore, this lab will demonstrate how to backup and restore your Aurora database instance. So Aurora backs up your cluster volume, so the disk automatically and retains restore data for the length of the backup retention period. Aurora backups are continuous and incremental, so you can quickly restore to any point, so point in time recovery. Within the backup retention period, so no performance impact or the interruption of database service occurs as backup data is being written. So there's no performance impact when you do a backup, right? Any interruptions. So you can recover your data by creating a new Aurora DB cluster from the backup data that Aurora retains, or from a DB cluster snapshot that you've saved. So you can quickly restore a new copy of a database cluster created from backup data to any point in time. So from backup data to any point in time during your backup retention, backing up and restoring an Aurora DB cluster. So this lab contains the following tasks. So one moment. So select a backup retention for the automated backups, create the manual snapshot, restore from a manual snapshot, perform a point in time recovery. Okay, so let's do this, just a moment. Okay, so automatic backup retention. So in this section, we are going to demonstrate how to change the automated backup retention period for your Aurora cluster. AWS handles all of the heavy lifting of managing the automated backups for you, and you can specify a backup retention period from 1 to 35 days when you create or modify a database cluster. Aurora backups are stored in S3. So region check, ensure you are still working in the correct region. Yes, I believe I am. So especially if you're following the links above to open the service console at the right screen. So select the database instance, Aurora Lab MySQL cluster from the AWS RDS management console. Click to modify. Click on modify. Select the maintenance and backups. So basically I've chosen this, just a moment. DB instances. Let's say I choose this. So if I click it also, I think I'll see modify. No, I don't see modify here. Interesting. So let's just click this and upgrade required for a database. Manually upgrade a database or transition your database extension is available for your extension isn't available when automatically upgrade after that. To upgrade manually, choose modify for the data. If you have any questions, okay. I don't know for which database it's required. So you may want to consider using Blue and minimize your downtime during upgrades. Staging environment, okay. To production for changes to production databases, easy path homogeneous data migrations, okay. Then powered by AWS DMS data migration service, I think, and so leverages simple and performant data migration from EC2 database to equivalent RDS database, and choose the migrate data from sure you check the supported engine and feature limitations. Introducing global database writer endpoint that you can use to send your applications request to the writer instance in the primary cluster of your global database. Okay. So Aurora automatically updates the endpoint upon a cross-region failover or switchover operation, ensuring that requests are routed to the writer instance in the new primary cluster without the need for changes to your application code or configuration. Interesting. IO Optimize is a new cluster storage configuration that offers predictable pricing for all applications and improved price performance with up to 40% cost savings. Okay, for IO intensive. Aurora MySQL version 2, MySQL 5.7 component is auto enrolled into. Okay, which one are you talking about? There is no version mentioned here, huh? Or is there? Maintenance, current activity, maintenance, VPC. Recommendations, non-informational, upgrade to latest engine version. So this is backtrack. So 2 informations, 1 high information, upgrade. I think this is like a upgrade thing. Auto enrolled in RDS before October. Okay. such as impact increase in changes due to increase in charges, not changes, due to RDS extend support and category cost optimization. So yep. So now they're talking about that only is auto enrolled. Version 3 with MySQL 8.0 compatibility to avoid additional charges. Okay. So now I'll just choose this and click on modify, and let's keep this close by. So here automated backups, observe the retention period of the backups. So select the maintenance and backups tab. Okay. Additional, I think this is the tab we're looking for. So there's no tab specifically over here, but it's okay. Oh, I have to not click that. Instead, I have to, I think, click this and then maintenance and backups. I can't apply or do anything. I can't change it, but I have to click the modify over here now. Right? If I click this, I can still click modify. There's no maintenance and backups and stuff mentioned here. Minor version upgrade enabled and all. For this one, there is snapshots and everything mentioned, and backup stuff may like mentioned over here. So I'll just click modify. Oh, it still goes to this only. Okay. So backup. Okay. So in this section, you'll find the details about the current maintenance and configurations and backup details. So the event ends in 1 hour, so I'll just try to finish it. So current maintenance configurations and backup details. So automated backups, observe the retention time period of the backups. The earliest restorable time specifies how far back within the backup retention period that you can restore your thing. Retention period is 1 day. Start time is this. Okay. So 1 moment. Earliest restore, nothing was mentioned here. Okay. So earliest restore time. So I think this is all mentioned here. 1 moment. If I click this, so here in maintenance and okay, click this and maintenance and backups. So earliest restore time is July 2nd, 1:49, and latest is till today. So this I can do, and backup window. So the latest time to which latest or last time to which a database can be restored with point in time restore. Earliest restorable times, which is how far back within the backup retention period that you can restore your instance. Backup window details. So to modify the backup retention period of backup, you can click the cluster and click modify, and you can change the period and all. So in modify, here modify the backup retention period by selecting 7 days and click continue. Okay, so let's just change this. We'll change it to 7 days and click continue, apply immediately. So continue, apply during the next time, apply immediately. So modifications in this request and any pending modifications will be asynchronously applied as soon as possible, regardless of the maintenance window setting for them. So this is a maintenance window actually, but we'll just apply it immediately, and it is done. So yep. Snapshot cluster, while Aurora backups are continuous and incremental and retain backups up to 35 days. If you want to retain a backup beyond the backup retention period, you can also take a snapshot of the data in your cluster volume. You can create a new DB cluster from the snapshot for testing with seed data. So you can have some enough data, right, and seed data. So to quickly restore to a known good state before a change control or any number of other cases. In this section, we'll learn how to create manual snapshots to augment your automated daily backup strategy. So if you want to retain backups more than 35 days, then you'll have to do this only. So take snapshots. So select the DB instance Aurora Lab MySQL cluster from the thing. Take snapshot. Aurora Lab MySQL cluster. So it is this one. Basically, the others are IO optimized, backtracks, serverless, standard storage, and whatnot. And then actions: stop temporarily, start database activity streams, set up EC2 connection. cannot be related to it. Isn't supported because the cluster doesn't have a replication source identifier, and you need to first delete or remove the DB instances within the DB cluster. Backtrack is not supported because DB cluster doesn't have a backtrack window. Okay. So here, where is snapshot? Create clone, take snapshot. So restore 2.9. Okay, so take snapshot for the cluster or the instance is the question. So provide the identifier for the DB snapshot as cluster snapshot. Okay, then click it. So I think this is for the cluster only. Snapshot name is this. Instance, no options. For cluster, yeah, there are options, right? So and name, okay. So snapshot identifies case insensitive, but stored as all lowercase. So yeah, you cannot have end with a hyphen or have two consecutive hyphens, and it was start with a letter and it's alphanumeric also. So that is done. It's creating the snapshot. I'll close. Okay, I'll just open the others. This was successfully modified, and this is creating the snapshot. So we can see the snapshots over here. So you will be redirected to the snapshots overview screen. You should see a snapshot in the manual snapshots list, and you can see the status of the snapshot in creating status and progress status during the stage. So it's creating status now. Progress is 0%. So during this stage, the DB instance is in the backing up state. It will take a few minutes for the snapshot to be available. So if you go and look at the databases, it should say backing up state. Here, Aurora MySQL cluster. So this one says backing up, right? So that's what's happening. You'll be able to see the snapshot name and the time it was created once the snapshot is completed. This might take a few minutes depending on the size of your database. Okay, so I think this is going to take some time. It's okay. When was it created? I mean, creation is written here, instance here, and database. Okay, so we just clicked it, right? So snapshot creation time, DB instance created time is this. So this was the snapshot creation time. Creates a storage volume snapshot of your DB cluster, right? So it creates so Amazon RDS creates a storage volume snapshot of your DB cluster, backing up the entire database cluster and not just individual databases. You can create a new database cluster by restoring from a database snapshot. In this lab, we'll see how you can restore the snapshot into a new cluster. To begin, return to the AWS console, navigate to the RDS service, select snapshots. Next, select manual snapshot, this snapshot checkbox, then click the actions drop down menu and click restore snapshot. Okay, so this snapshot is not yet created, so I'll just read through this for now. So you'll now be redirected to the restore DB instance page. Let's select the DB engine available version and provide the Aurora lab MySQL cluster restored cluster as the new database instance identifier. So this, I remember it being a different version, or was it? I don't know. I should check the version it is. So I remember it being. What is the version? Information monitoring recommendations. I want to see the version this is in. So status backing up, okay. How do I know the version? Manage IAM roles, connected resources, proxies, monitoring, configuration. So this is 06 by the way. So this is not. So engine version is 06. So I'll just take the 06 itself and not. So this one is still creating. Progress is 0%. So this is 3.06.0, so I'll take that itself and provide instance for instance choose R7 large. Why though? I think R6 is enough. Anyways, So in connectivity, choose Aurora Lab VPC, Aurora DB subnet group, and a database. Okay. I think this is available now. So now you can click this and say action. If you don't click it, okay, great, view details. Great, so it just opened up the thing. You can actually go to it by this also. So you can just click snapshots. Can't click actions until you click this, and then you can click action, restore snapshot, export to Amazon S3 and all. So restore snapshot, and this has chosen the correct thing. So I don't know why they chose this though. Provide this, so I don't know, maybe this is kind of like an upgrade, I don't know. So I mean, it says this is also available, default for major version. Okay, so now DB instance identifier, this cluster configuration, Aurora standard and all. Select Aurora Lab star ER as your cluster parameter. Okay, so standard memory optimized, yep, R7 large, yeah, that's what is chosen actually. Interesting. R6 large is what I had chosen before, R6 large, but this time it's R7 large. I wonder what's the difference. R6 large 4750 Mbps network, R7 large, this is R7G, R7 R7G large, network up to, okay, the network is different, okay. And then Aurora Lab VPC, DB subnet group, public access no, security group, Aurora Lab database subnet security group, right? So subnet group, availability zone, do you need anything? Nope, I think it's fine. This is the same availability zone, I don't know, like port. So in additional configuration, I think we have to say the parameter group. So this one, I think parameter group, okay, this is not the one. So I think it is this MG, basically the one with 3 hyphen or 3 BK. So, and then this, yeah, and then finally restore DB. So you should be done. You should see your new instance in your list of databases in the creating state. It will take a few minutes for the instances to become available. Connect and verify restored instance. Okay, when the instance becomes available, select the thing and copy the endpoint in the connectivity. And if you have not already opened it, and just give the username and password. I think it's the same username and password, so I'll just use that. So once you're connected, we'll check that the data is the same as the original. So by performing a checksum, so yeah, on the new terminal, just connect to the other one and run the same query, and yeah, we'll be checking out this. So this is the snapshot, and there are actions on, oh, this is not the snapshot, this is Aurora DB MySQL cluster. So I'll just restore DB from here. Okay, this is taking some time. So there it is, it says this. So we need to wait for this to come up. We'll choose this instance endpoint name. So this will be the other endpoint. We'll just say MySQL -h, and the username and password is the same. So I'll just say that. Once this is up and running, I think we should be good. Till then, I think we can look at the other stuff. So I'll copy this also, and this. Yep. So that is that. Let this be in creating state. Is being restored. Cool. So check some values are identical in both servers because they're the same image from when you last made your changes. Okay. Restoring a DB cluster to a specified time. So you can restore a DB cluster to a specific point in time. Creating a new database cluster. Point in time recovery or point in time restore is the process of restoring a database to the state it was in at a specified date and time. In this lab, we'll use the console to execute a PITR on our Aurora cluster. So please follow these instructions, and so after successful connection, just run the following queries. Select current timestamp and this. Okay. On which cluster though? I don't know. Okay. Now we'll drop the table in the database by running the following queries. We drop it. Okay. And then quit. Okay, one moment. Let me just check if this is created or not. This is still in creating app. And then perform point in time recovery. Okay. I mean, this is being restored. I will do all the checks. Then I still haven't done some of the checks that they mentioned. I will check if the restore was right and choose restore to point in time. And then under the restore time, choose a time prior to you dropping the table in the instance database. You can also choose to have enter. You can also choose to have a enter under the deviance. Okay. Okay, I don't know. They made some mistake here. Okay, enter this. Please note the timestamp in the database may be a different time zone to the AWS console. So please confirm before entering the time value. So this is basically what time zone, I don't know. You need to understand the time zone, that is tricky. Configuration time zone. Okay. Cool. So I'm not able to find the time zone. Wait, MySQL server time zone. So checking the select global time zone. Okay. Cool. So I think we can actually find out this. Default behavior increment and server time is initially used for that connection. You can change the time session time for a specific connection using. Okay. So I think I can use. Okay, let me see if this got created. This is still in creating state. I can use this apparently. So let me just see if I can actually just say what is the time zone, system time zone. Okay, how do I know what is the system time zone? Get MySQL server time zone. So we'll return the global and session app setting. This means using the server, you can also select system time zone to get the server system time zone. Okay. So select UTC. Okay, so that's fine. Session time zone is also UTC, I'm guessing. Yeah, it's system which is UTC basically. Linux server time zone, get Linux server time zone. If you mean from the shell, just type this. Okay. What is the default time zone? Thinking UTC. Up. So it is UTC. Let me see if this got created. Nope, it hasn't been created yet, so it's okay. Okay, so it says this. So you can give UTC maybe. Leave the rest as default and scroll to the end of the page and click point restore to point in time. Where you should see now we should now see your new point in time recovery. It will take a few minutes for the instance to become available. Okay. Snapshot. This is point in time recovery. Connect to the end check. Run the checksum. This should match with the previous checksum matched. Okay. So, yep. Interesting. So this got created, and now I'm actually going to check the connectivity with this. This is the endpoint name. So I'll just say, okay. Let me change this. This is called the restore cluster. Okay. Yeah, this is the restored cluster. Now, let me run this here, the restored cluster. Oh, it says unknown my host. Okay. Oh, the endpoints are still getting created, I think. It's not available yet. So I can't use it. Okay. For this, it's already created available. So there is one snapshot, and this is an automatic one, I think. So automated, and this is manual. Yeah. Once this is created, I think I should be able to connect. We'll wait for that. The writer instance is still not available. Cool. I can still run this and see the checksum. So the checksum is this 232.142.4769. Interesting. Cool. So now auto scale read replicas. Okay, there are a lot of things. I don't know if you can finish it in 41 minutes, but let's try. I should have tried this before itself. This lab will demonstrate how auto scaling read replicas work. Okay, so you'll use a load generator script to send traffic to the reader endpoint of the DB cluster. Once this load is detected, Aurora will provision an additional reader instance to distribute the read traffic. So we are only doing read traffic load. Run a read-only workload, observe read replica auto scaling. Okay. So let's see if this is working. I'll come back to this. So for this, you'll use the reader endpoint of the cluster. You can find the value in the CloudFormation stack. If you have not already opened the terminal window in the VS Code ID in a previous lab, please follow these instructions. Okay. Run the loads generation script from the terminal window. Replace the reader endpoint placeholder with the reader endpoint. Okay. So yeah, this one is not coming up, so we'll just use this for now. So for this connectivity, so we'll be using the read only, and let's see this. Okay. So this is the endpoint, and this is the DB user, which is administrator, and the password is this. Cool. So we are now running that. So we'll run this. So it's sending queries, I think. We can do control C, so it sent 111 and all. Report the number of queries it is sending to the database per second. So take note that the reader node is currently receiving load. So we should note it over here, how much CPU is being used. So this has taken, this is the reader instance, right? So 10%. So this should get more load slowly. Current activity. Let's see. So this is sending 126 queries per second. Okay. So it may take a minute or more for the metrics to fully reflect the incoming load. Okay. So after several minutes, return to the list of instances and notice that a new reader is being provisioned to your cluster. Okay, nice. Auto scaling. Once the new reader becomes, note that the load distributes and stabilizes. It may take a few minutes to stabilize. You can now toggle back to the and control. So quit the load generator. After a while, the additional reader will be removed automatically after several minutes. While you're welcome to wait until that happens, you may also proceed to the next lab at this point. Yep. Cool. So I will proceed to the next lab. So clone a DB cluster. So is this even created? Nope. This is also getting created. This is also getting created. This one, this will take some time for the CPU percentage to show high. We'll come to that. So this lab will walk you through the process of cloning a database cluster. Cloning creates a separate independent database cluster with a consistent copy of your data set at the time you cloned it. Database cloning uses a copy on write protocol in which data is copied at the time that data changes, either on the source databases or the clone databases. Okay. So copy on write. So whenever there's a write, it will copy. So the two clusters are isolated and there's no performance impact on the source DB cluster from database operations on the clone or the other way around. This lab contains the following tasks: create a clone, verify that the data set is identical, change data on the clone, verify that the data diverges, clean up the lab resources. Okay. So if you have not already opened, okay, DB security group and all placeholders. Okay. Cool. So we'll just copy this. Is the load increasing here? It's actually decreasing, but the number of sessions are different. Cool. So I'm just gonna go ahead and run this for this subnet group. I will get the subnet group from here, and the security group is here. Cool. So it says restore DB cluster to point in time. So it's cloning. So restore type copy on write. Use latest restorable time. Source DB RMX. Okay. Cool. So DB cluster identifier MySQL clone. So now I will probably use one more terminal. So yeah, and I'll run this. Oh, now it is available. The restored thing is available, and this is also available. And I'm also, but this is still creating. The endpoints have to be created here. So cool. I think it's done here. So basically, it has created a database cluster, allocated storage availability zones, backup retention period 7, database name. Identifier is clone, and same thing. It's in creating state. Endpoint is this. Reader endpoint is read only this. Multi availability zone false. Aurora MySQL 3.06.0 administrator. Password is not given here, I think. And KMSK ID, cluster resource ID, cluster ARN, engine mode, provision, tag list, and all that. Cool. So it is there. So this one, let me just check this snapshot thing, restored cluster. Okay. I'll just go back to databases and see that there is a clone. So there is a clone here. It's getting created. So let me find it. It's here. This is creating. So here I can just say this. Check the status of the creation of your clone by using the following command. The cloning process can take several minutes. Okay. So this, Cool. So it is creating, and the status is creating, and the endpoint is this. Right. To take note of both the status and the endpoint, repeat the commands several times if needed. Once the status becomes available, you can add a DB instance to the cluster, and once the DB instance is added, you will want to connect to the cluster via the endpoint value, which represents the cluster endpoint. Cost optimization, creating a data even without adding new instances can be useful in cost-effective safety net measure. If you're about to make significant changes to your source cluster, such as an upgrade or risky DDL (data definition language operation), so the clone then becomes a quick rollback target in case you encounter issues on the source as a result of the operation. You simply add a database instance and point your application to the clone in such an event. Not recommending using clones as long-term point-in-time snapshot tools, as you are limited to 15 clones derived directly or indirectly from the same source. If you clone from A and you get B, and then if you clone from B you get C, the same source is A. So add a DB instance once the status of the cluster becomes available using the following command. Okay, I think the cluster has become available. So here you can see it says it is gonna say available. So now you can actually create a database instance, R6 large, Aurora MySQL clone instance. Cool. Let's look at that. So this is describe and cluster identify and all. So just gonna put that in. Cool. So it has created a database instance, I think. So it says database instance here. In the previous one it said database cluster, I think, DB cluster. So it says DB instance now, identifier, class and whatnot and everything, and then the parameter group and all that. So security group and everything. So all of this is there. So you can actually look at this being created, and here you can actually see the auto scaling happening, by the way, for the MySQL cluster. And you should see the load being 38%. So once you stop the load, I think it should stop. Let's see the auto scaling happen, and then let's see it reduce. So this is the restored cluster. Oh, by the way, I didn't run the thing in the restored cluster, right? So maybe I will do that. One moment. I will leave this thing. Keep this going, and I'll use a different thing, and I'll just say split terminal. Oh, why can't I split? Split terminal bash. Okay. So I actually wanted to do this too, which is connect to this cluster and say checksum. This one right here, then connect to this cluster, and this is the restored cluster, as you can see over here. So, and then check the checksum. It's taking quite some time actually, but we see 232.142.4.769, 232.142.4.769. It's the same. So now I can actually delete the thing. In between they are asking to create a restoring a DB from a point in time. I can delete this restored thing once. Maybe I can just kill this off. Go here and say stop temporarily. How do I say delete? Can't delete because I have to delete the DB instances first. Okay, delete me. So this is the restored cluster, so I'm just going to delete it, and then I can delete this also. So final snapshot name, retain automated backups. Create final snapshot, no need. I don't need a final snapshot. Delete me. Snapshot name, retain automated backup, including will no longer be available. Yep, I'm fine with that. Cool. So both are in deleting state, I think. No. So can actually see that deleting DB instance and this is also being deleted. Awesome. Cool. So this should die in some time, I think. This should remain, and I should just run timestamp and check the thing over here, paste, and timestamp is this 10:12:57, and I can just go ahead and drop the table. So it's 10:50, 10:12:57 is the timestamp, right? So is when it was everything was running, and the checksum is this. Now timestamp later is this. So let's look at this. So now I can just perform a point in time recovery, restore to point in time, and then see how it works. So for currently this shouldn't work, so I'll just say this. I can't drop again now because it's already dropped. I can't just drop again. And if I check the current checksum, it's this, it's null. So now I can actually go to the databases thing and restore cluster. Okay, yeah, this isn't deleting. Great. I don't need it. So yeah, this one, look at PITR, restore to point in time, here or in the main thing. Like even here it should show. So MySQL cluster, this one it's modifying for some reason. Anyways, so restore to point in time, and DB instance identifier, I think we don't need that. Oh, we need it. Okay. Aurora lab MySQL PITR. Okay. Okay. Standard, everything is fine. Security group, subnet. Okay. Didn't say what time, huh? Latest restorable time. Custom date and time, UTC 5:30, huh? Okay, so I got the time as this, plus 5:30 will be 2025-07-03 15:42:57. Yeah, we can say 15:42:57 or even 54, this one also, because this time is basically 2025-07-03 15:30, so 43:12. Anytime before the delete, basically I dropped it and then quickly I said delete. So and when it was available, it was actually this. So UTC plus 5:30. This one is just UTC. This one is UTC. This one is UTC plus 5:30. Okay, so I can actually say this time, or I can actually just choose third. Yeah, this. So this is UTC 5:30, right? So 15:42:57. I think you can't do this, 15:42, because 42. '57. Let's see if it allows me to do it. I think this is the latest. I can't do beyond this. Let's see. Let's see if it can do it or not. So this is getting created. Yeah, so while this gets created, we have 20 more minutes, so let's do other stuff. We did clone, change the data and verify the data set. Okay, so did the clone work? I don't know, I have to go check. So databases, This is the clone, this is here. I need to connect to it. I cloned it. So I said create DB instance here. So it's here. Yeah. So I said create DB instance. Now I need to actually just say describe and this should just work. It should say the status is available. Repeat the command and then finally you get the endpoint and you connect to it. So endpoint, how do you get it? You get it from the clone over here. So that is the endpoint and it's available. So I'll just use the endpoint and let's say I just say this. Okay, so this is the clone. Let's see if we can access it. Why does it say creating now? I don't know. Restored cluster deleting, okay. For PITR it's creating. For cluster this is available. And what is the load on these? I think the load on this is still a lot. Oh, now it's okay. I think I should just stop. I think I should just stop. Oh, now it doesn't exist, so it just stopped, however. So at some point I think it stopped because I removed the table. In between I removed the table, so yeah. That's a lot of logs. Anyways. Cool. So this should go down. The reader instance should go away. Now thing is, verify the data set is identical. So basically in between we removed the data, right? Anyways, but when we created this I think it was all fine. So let me still try it out. This is the clone and let me try out the checksum. It's taking quite some time. Okay, so 232.142.4769. Yep, it's right. And yep, you can quit next, connect to the source cluster with the following sequence. Execute the same checksum command that you ran on the clone. So it should be the same, and you can change the data on the clone, so and execute the checksum. So you can delete one row. So here you can delete one row, check the checksum again, it's different now, and okay, wow, it's the same thing. And now verify that did not change on the source cluster as a result of the delete operation. Yup. Disconnect from the clone if you're still connected. Connect to the source cluster. Execute the same checksum command that you ran. Instead, should be the same as calculated for the source cluster above in section 2. Clean up lab resources. Okay, so I can clean this up. This should just die off. This one is the clone, and yeah, however here I'm connected to the clone. here I'm connected to the clone. I think this I can delete. Connected to the clone. I want to connect to the main thing. Oops. What did I? Yep. So I have to do these. I think no matter what over here, cluster. This is the restored cluster. Yeah, this is dead. This one. Section is null for now. We can run the clone deletion. So this would delete the cluster and the instance. So basically first delete the instance and then delete the cluster. So next, so backtrack a DB cluster, database insights. Okay, that's a lot of things. Okay. So backtrack is not compatible with global databases. Please note that backtrack feature is currently not compatible with Aurora. By using a cluster specifically built for backtrack, you will not be able to use this cluster for global. Cool. Let me just read through these. Reminds the DB cluster to this time you specified. While it is not a replacement for backing up clear purposes, backtracking allows you to easily undo mistakes quickly or explore earlier data changes. Backtrack to recover from unintended data changes. Okay. And let me see if this auto scaling went down. No, it hasn't gone down yet. But the load has reduced. In some time, I think this should go away. And here the clone should be gone now. Yeah, it's in deleting state. The point in time recovery thing should be up now. It's still in creating state. Okay. And make unintended changes and backtrack to recover from unintended. So you need to retrieve the DB cluster endpoints, backtrack cluster, reader endpoint, and should be used for both. The reader endpoint will resort to okay, of course. So note these values. Okay. So connect to the cluster, and these are just the. So we are dropping the thing. So okay. So we need to connect to this database. I'm wondering, I think it should be the same credentials. Let's see. So backtrack cluster, you get this. So you do this and you connect to this. This is the backtrack cluster, and so you connect here, and then so you create a procedure. Okay, done. Load an initial data set. Okay. Create table. Okay. Load the data set. Okay. So this will take some time. Okay. Then drop table, make unintended changes. Okay, so we do this. Once the table comes back, get the timestamp and then drop the table. Okay, remember to save the markers displayed as error. Okay, you will use them as references to simplify determining the right point and time to time. Sysbench. Now run the following command to replace the drop table. Using the sysbench command, replace the cluster endpoint with the cluster endpoint. Okay. Number of concurrent threads, cluster endpoint, username, password, port, number of tables to create. Okay. So this should create things. And after this we should do some stuff. I'll note down the details for that. Cluster endpoint, username, and password. So I need to check out the timestamp here and quit once I drop it. Okay, so here so this is the select, yep, and then drop table and this query. Okay, rows affected. I think now drop table won't work because it's not there. Now we'll be doing sysbench. Okay, creating table and it's doing this, and so the time is this. We need to take care of this. For backtrack to this UTC. Okay, so now checksum reconnect should be okay. Yeah, of course. Checksum should be different. Yep, this is done. So once you do this, oops, let's copy this. Checksum should be different. Okay, of course. And now you backtrack, is it, to recover. So right after dropping the table, slightly after the second time marker, right after dropping the table. Okay, basically they want the table to be missing, that's all. So now basically the second thing that we saw was after dropping the table, it was time was 10:29. So backtrack to before dropping table, after dropping table. That's pretty quick actually. That's gonna be pretty quick. That's gonna be tricky, but okay. I'm just gonna say this and let's see how that works. I need to actually just say this. maybe just do, okay, copy this and understand how to put it this format. So I think it's pretty straightforward. In between T has to come and then H okay, cool. So I think I can do this T. I think that's it. So looking at the thing, yep. Run the below command and okay, and you can run the describe cluster to see the status. Pending, backtracking. We'll let it backtrack and it should say it's not available, and then now backtrack again to a time slightly before the first time marker, right before the dropping the table, and you should have the table. Okay, cool, interesting. CloudWatch insights. Okay, so the performance insights is dead. So I mean, it's going to be dead after November 30. So that's the end of life. After this date, no longer support the flexible retention periods and their associated pricing, which is actually database insights is basically the next level of performance insights apparently. So monitors your RDS instance, Aurora DB instance load so that you can analyze and troubleshoot your database performance. Database insights presents metrics in a single dashboard for all databases in your fleet, allow you to monitor all your databases simultaneously. You can also test apparently fault tolerance and yeah, a lot of things. I might not be able to do all of this. So activity streams, there's so much more. Hopefully maybe some other time I'll be able to try out all this when the thing is available. For now I think I'll just go ahead and, so how do you enable, this is available. So now if you just connect to the DB, does it have it is the question. So it does have it and it has the old thing. Wow, interesting. Basically it went to the time when before dropping, I think after dropping it would have gone, but anyways before dropping it went. So we have directly gone to the time when it was gone. So now we have gone directly, basically we did create a and then we said time 1 drop a and then create b. Oh, by the way, before dropping, I mean after dropping we have to get the time, but anyways, and this is time 3. Time, basically we wanted to go to time 2 first and then go to time 1, but yeah, it went directly to time 1, which is just after creation and the data. Anyways, so basically do advanced database insights advanced mode, scheduling of modifications apply immediately. Okay, so I think in monitoring you have to say advanced instead of standard and you're done. So generate load, and basically you generate load. So once connected, close it up. Document name, command document to run on your before. So it's a command document that you run basically. Sysbench test. So you run this and it'll run to execute this command on additional command parameters. So when you run this, I think instance ID token, I think this is to get a token for this call, for getting the instance. basically the instance where the VS Code is running. That's why this is the metadata service. So yep. And finally, you can actually see the insights. Look at the monitoring database insights, and you should be able to see this. And fleet health, database health, and all. And instance state summary, and then events and whatnot. And CPU utilization, it should increase, I think, because of the whole creation of load. So yep, use the top 10 instances per relative DB load. So you can read through this. And finally, database instance dashboard. So you can actually look at the instance level, not just the cluster level. So load analysis. So there are modes apparently. Database telemetry, and you can look at the other stuff. And finally, examine performance and all. Top weights, right? So this you can do. I think testing fault tolerance and other stuff, I don't think I'll be able to do it now, because where is it? So this is one, and then observe and identify, analyze query performance, drive it on to Aurora security, and IAM, database activity streams, Aurora global database labs. Well, there were a lot of things, but I missed, unfortunately. But I think I'll do it some other time. Yep. That's all I had for this video. I will see you on the next one. Let's see if this dies. You have been removed from the event. This event may have ended, or joined another event. Cool. So that's all I had for this video. I'll see you on the next one. Bye bye. These, will they be accessible? I don't know. I think they should be accessible for some time.